So here comes the next question on logarithm. Find the number of values of p that satisfy the equation. Log q to the base p plus log q square to the base qp plus log q cube to the base log q square p. Let's just do them. So log q to the base p, log q square to the base qp. Can I say 2 log q to the base qp? It can be written like this. Plus I have log q cube to the base something, so this can be written as 3 log q to the base q square p. Okay. Now the important information here is q is greater than 1. So we will keep that in mind. Moreover, can I say p is in the base? So therefore p will also be greater than 1. There is no doubt about it. P will also be, sorry, greater than 0, because the base of a logarithm can never be less than 0. It will be positive and it cannot be equal to 1 as well. So now I have log q to the base p. Here I can use a base change formula and I say log q divided by log qp. At this stage, what is the base? You can write the base as anything because we already have log q with base p. I am writing the base p again over here, plus 3 log q divided by log q square p. So again I am taking the base as p here for both of them. So at every place I am getting log q to the base p now, right? Therefore only I did it. So log q to the base p plus 2 log q to the base p. In the denominator I have log mn. Log mn is log m plus log n. So log m plus log n is log q to the base p plus log p to the base p, which is 1, plus 3 log q to the base p. In the denominator I have log q square to the base p, which can be written as 2 log q to the base p plus log p to the base p, which is again equal to 1. Now I just have log q to the base p everywhere. So let's call log q to the base p as, say, x. So what has the equation become? If you completely look at this, it has become x plus 2x by x plus 1 plus 3x by 2x plus 1, and this whole thing is actually equal to 0. This whole thing is equal to 0. But now this somehow tells me one thing, the one important point over here, that I have to solve this completely to get the answer. Can we do something over here? Let's try. Q is greater than 1. Can they all become 0? See, I have all positive terms over here. If I have all positive terms, they can become 0 only if x is negative. Keep that in mind. If x is a positive number, it is positive, it is positive, it is positive. So how can 3 positive numbers add up to 0? So either all of them are 0, but if all of them are 0, in that case what would I have? That means log q to the base p is equal to 0. So q will become p to the power 0, which is 1. But question says q should be greater than 1. So all of them cannot be 0. What if x is negative? If x is negative, that means I have log q to the base p less than 0. So q is less than p to the power 0, that means q is less than 1. But q cannot be less than 1 as well. That's also a problem. So q cannot be less than 1 according to this. And here also I am saying this, that they cannot be negative. If they cannot be negative, they cannot be 0. So all of them are positive, and positives can never be 0. Therefore I can surely say there is no value of p that is going to satisfy this. So my answer is option A, which is 0. This was slightly difficult question, lengthy as well, because logarithm is a concept in which not many people are very comfortable. So in my opinion, probably students would have left this question, but yes, not doable, I can say, at this stage. So the answer for this question is 0.